Thank you everyone for logging on and attending. Again, I'm always kind of staggered by all the response and stuff. With so many new people joining the community, it's always good to just have a little reminder of why this community started. It's an independent MuleSoft meetup group, so we don't receive any funding, marketing, swag, support or anything from MuleSoft. It's completely independently run. We facilitate that along with partners, and we've worked with Deloitte. Tonight it's with Integration Matters. There might be Capgemini, might be QuadCorp, loads of different MuleSoft partners and consultancies within the ecosystem to kind of make this work. So again, thank you everybody for your support, and just to say that it will always remain that way. We provide MuleSoft skills to MuleSoft partners, MuleSoft end users, and even in some aspects indirectly through MuleSoft professional services as well, on a freelance and permanent basis. So if you're looking for skills or you're looking for a new job, that's who you need to speak to. And the reason why this started is because we felt that there was a bit of a gap in the MuleSoft community for an independent meetup. A lot of the MuleSoft meetups are run by the vendor, which is MuleSoft, and it's great, fantastic events, and we attend all of them. And even global events, we've been over to Frankfurt, to the Connect, to London, and all sorts as well. But I think this just opens up a slightly wider discussion around integration, microservices, APIs, integration challenges, and allows the community to get under the sort of nuts and bolts of really what's challenging people. Again, I'm just staggered by this. The group's now grown to over 600 members in 2 years. So thank you to everyone for your support. The meetups we've done in person, the meetups we've done online, everyone's involvement, contributions to slides, presentations, a lot. There's people in this room today who have presented at them as well. And everybody's involvement and the fact that it's owned by the community has made that happen. So that's amazing. And as far as I'm aware, we're still the largest MuleSoft meetup community in Europe. No one's corrected me yet. And definitely the MuleSoft independent meetup globally, probably where we've seen such growth, where we've been doing events online, where Third Republic are now kind of pushing into new territories in Europe. We're starting to see people from the UK, Europe. We're working with Integration Matters tonight, which are a German and Netherlands-based MuleSoft partner. We kind of identified that there was probably a little bit of a need to grow and expand and potentially even rebrand. So a bit of an exciting bit of news. We're called the London MuleSoft Developers. It's got a load of connotations that it's just for people in London and you can only be a MuleSoft developer, but we get architects, product owners, CTOs, CIOs, heads of integration platform owners, everything turn up from all sorts of walks of life. It's not just the UK now, we're doing online. People are not just from London, other parts of the UK, Germany, Benelux. We've got people from India, and even we've had people from the US online as well. So we felt that a slight rebrand might be necessary. It doesn't affect anyone, it's just the branding of it. But wanted to hear sort of people's feedback. So feel free to comment in the group or on the chat on what people think of this. But rebranding as the UK independent MuleSoft practitioners, what that allows us to do is also allows us to roll out meetup groups in other regions like DAC and Benelux as well, which we're going to be working with MuleSoft partners to do. So the community is growing. Hopefully that will mean as we host more events in person or in line, that there's more access to more content, more people, more network, more growth, still retaining that community element that is run by this community. Yeah, I hope you all enjoy the talks and stuff tonight, and I'll be participating throughout as well.
Hello everybody. Great to see this big audience tonight. I'm really seriously impressed by the growth the meetup had and the audience we draw tonight. I'm Hendrik. As has been said, I'm out of Germany, running Integration Matters, a little consulting and software shop in Germany, and we have like 300 customers globally for the software piece. Tonight I want to talk about my experience, my insights into implementation of an event-driven service mesh, and I hope you find that interesting. So my background is I am an integration enthusiast for the past 22 years. I'm integrating our customers' digital processes for 2 decades now, using a very pragmatic approach. I try to apply technologies to real problems and real technologies. So it's not like from the ivory tower, but this is like getting things done, getting the hands dirty and make things work in real life and not just on PowerPoint. Over the past years, I've developed integration solutions for many different industries. In a previous life, I used to be, for a global integration player, the integration architect for energy and utilities across Europe, some other regions. So that is the experience I draw on in my more recent engagements. And I'm really passionate about monitoring automated businesses in large scale platform using our own product Ngems, which is able to monitor distributed environments and the business process aspect of that. When we talk about an event-driven service mesh, I cannot talk about like what the future holds and where we are currently without looking into the motivation why we do this. And the real need for integration has been there since ever we invented IT, really. So we need to keep the information consistent across our systems in the enterprise. Inconsistent data, bad data quality is the death of every customer experience we're going to have, and it's going to cost us a lot of money. We also do integration for the purpose of decoupling our business processes from our business applications. Historically, we found that there have been obviously very specifically tailored applications to suit a certain need within the organization, but changing and updating them to more modern business process requirements is quite cumbersome and low. So what we really try to do in integration is let's invent new business processes, have them being modeled outside the application, and just orchestrate the applications and the systems and the data and the humans that we have within our organization, so that when there's a change in demand for our business processes and we need to adopt them, or we want to invent new stuff, we do not necessarily need to touch the existing business applications. So hopefully, over the course of doing integration for the customers, for our companies, we increase agility or the capability to adopt to changes in the business requirements. Looking historically, where we came from, there have been a bunch of methodologies that try to address this topic for a long time. And that is, well, in the very beginning of IT, we just put it all on one hardware box and into one application. So in nature, everything was integrated. And the downside of that was if things needed to change, we needed to get the programmers and we need to put the change in so that our application logic would change. And then other players appeared later on in the market, much later in the market, where they said, well, our philosophy is not having it all in one single application, but we integrate stuff by putting it all in one massive database. And there's major players out there that still believe that putting all the data you have in a single database is the solution to everything, and you can do whatever you want at the speed that you want. Later, we realized that a single database probably isn't good enough, and we had multiple systems, multiple databases, multiple data sources, and we came along with ETL technologies and trying to extract data and load it into the systems, and that was the way on how data really was processed in batches. The audience is probably, I hope, very broad, and I just picked some of the distributed data protocols that I have encountered in the past, like 25 plus years, which try to address the need of integrating remote and distributed systems. And I'm sure all of us have touched like DDE or Decomplus or Corbar, which all try to address the same problem, and that is executing calling functions in a remote system to serve some business needs, some business purpose. Like in the early 2000 days, we had stuff calling like service-oriented architecture and web services, namely, that try to address stuff. So when you look at that, where we came from, we were very data-driven, very application-driven in the beginning. And in the end, we ended up trying, what we tried to do with SOA was being able to transparently address business services inside the organization without the notion of what is the underlying application, what is the underlying technology, what is the service contract behind that, but we try to anonymously consume these services. Tooling over all these days has been pretty unstructured, I would say. I've seen many different tools that had to be used to do any of these integrations. The tooling was demand-driven. What I mean by that is every team I met, they built their own tool chain, their own tooling. There was no standardized way on how to run multiple different integration aspects. So ETL was done a different way and monitored in a different way than web services were done and so on. And it was absolutely scarce. So the upkeep costs of integration in the old days was really extremely high. Not to speak about security. Security was a big mess those days. Nothing was really interconnected over the internet. Everything was in silos inside the organization, and nobody really thought about securities. And even if we look into some of the major data breaches today, that is typically because the architects behind that still think their internal systems, their internal networks are safe and secure from being hacked. So security really wasn't a big concern those days.
We're launching a poll. When did you start developing integrations? 10 years, 5 years, 3 years, 1 year, haven't yet started. Hendrik, you've said something very interesting on the previous side, which not many people really think of, which is actually when you're integrating, you're not just orchestrating systems, but you're orchestrating people. Can you talk a little bit more about that? Because that's an interesting angle to think about integration.
So when we look into what is the added value of integration? Like, what really do we want to do? We would like to add value to the business process. If whatever we do does not add value to the business process, we really shouldn't do it. So if what we do is not supporting the business in any way, that's bad. In the old days, it was very easy. We would help the business by just synchronizing customer data from the CRM system to the ERP system, for example, or synchronizing stuff from the order management system into the money collection system, into the general ledger. So that would already support our business processes. In modern world, we have more systems and we have human beings that need to play a role. As business transactions increase in numbers and they decrease in latency, we started building more clever systems that automate decisions. But if exceptions occur, if something goes wrong or needs clarification, we need to involve human beings. So without really breaking the business process. So being able to identify in real time whether a business process can proceed to the next processing step or needs manual intervention has become vital. And without being able to do that and step in time and call the expert to resolve a situation, again, our integration approach will be futile. It will not come up to its full value and probably create bigger challenges in the future.
So hopefully everybody can see the results now. About 44%, 32 of you have more than 10 years experience, 25% 5 years, 14% 3 years, 14% 1 year, and 3% haven't started yet. So you've got a fairly good mix of new joiners to the integration space, as well as kind of, let's call them old-timers in terms of being there, done it. Back to you, Hendrik.
Yeah, thanks. It's great to see that we have such a senior audience and to have the new starters here also. So where we are in the modern days, and I know MuleSoft says this is API-led development. Yeah. So, but what it really comes down to is when we are all the computer scientists in the room, we say, well, this is contract first development, really. So coming from a business requirement, articulating our need for a certain business function, we define the contract between the service and the caller, and that is really called contract first development. So once we agree on what the data structure should be and what the API should look like, that is when we start developing. And all of you that are MuleSoft users are used to that. We first implement our APIs and then we build out the clients and the service pieces from that. So that is what we do in modern days. First, we think about the contract and the data structures. We think about zero trust architectures, which means nothing we consume is granted a given. So we can't simply access resources. We should apply for resources, get authorization for resources, have the privileges to do stuff. And that is really what we should do as architects, to make sure that all the resources are secured and only authorized and authenticated users actually can consume our resources. In a modern day integration landscape, you typically have a centralized broker that is orchestrating, what I said before, the humans and the systems and the data. We have an independent data model. Now that is, depending on how long you are in the business, there's pros and cons of data models, but of canonical data models. But what we really want to have here is we want to have on our service interface an independent data model that addresses the business need and not the technical need of the underlying and connected application. So getting this right is one of the key things, the keystones in having a reusable architecture in the end. Happy today, we have a massive connector ecosystems. Like when we started integration, applications weren't thinking about being integratable. being integrated into a larger business process. Everyone had their own proprietary APIs, and nowadays what we see, new releases of applications that do not offer REST APIs are not successful in the market anymore. And there are some still bespoken systems like SAP, for example, or some of the Oracle stuff, where we now have connectors available that translate that from that proprietary API into a REST API. So we have an existing connector ecosystem, and we have a system model API, or that is what we create during our implementation efforts. And that is how we work today. So we think about the business need. We design our requests, our data structures around the business need, and we implement it in a centralized broker that allows us to orchestrate the resources and having that single source of truth about the advances in the business process. So that is really where we are today. All that is working or is getting triggered on stuff that we call an event, a business event. And I took that from the business dictionary. When we run our business, events occur in the business, and events trigger subsequent actions. And an event is well defined. It has a time when it occurs, it has a purpose, it has an origin. It not necessarily has a destination, it's just a piece of information that something in our business process has been updated or changed. And that could be an updated delivery address, that could be a settled invoice, that could be a new customer, that could be a new subscription. And then we need to deal with those.
Good point to launch our next poll. Are you familiar with complex event processing? So
when we think about events again, when you look into your integrations, you will have a myriad of events. You will have infrastructure events. You will have, like, from sensor readings, you have business related events. So the events I'm talking about are the ones that drive your business process or have an impact into your business process. So it's important to be able to filter and understand what event is important for me and which event is less important to me. And complex event processing actually helps me in identifying events that are important for me and require further attention, or that can be simply skipped and ignored.
56% are familiar with complex event processing, 44% are not familiar. So I think there may be some ground to cover on complex event processing.
It's a massive topic, actually. It's probably good for another speech, another appearance in this format. So the event occurs, and we detected the event, and now from an architecture point of view, we need to take a decision for our solution. And that is, do we want to handle the event in a direct fashion, or do we want to forward the event using an intermediate broker? And that is the decision, direct versus bus. Or today, the direct communication really is realized using HTTP. It is the number one business protocol currently, or business data transport out there nowadays. Messaging is around for 30 plus years also. So what are the pros and cons of doing that? I need to take a decision about whether my event that I need to process is of interest only to one single destination, or if I need to address multiple destinations. The one-to-many communication could be a good example from the retail. We have a customer, they run like 3,000 stores across Europe, and they need to update their point of sale information based on that single event. So they have a price change, and they need to push that out to like 3,000 or 3,000 times 4 point of sales cashiers desks. So that is obviously a one-to-many communication, which is obviously you would use messaging, whereas sometimes you only have a point-to-point communication where HTTP would be the protocol of choice. What we try to address, whether we use HTTP or messaging, really is we want to make a remote procedure call. So we want to invoke another business function somewhere and support that, and just remember the good old days of all the other protocols that I talked about earlier. We need to make a decision about, is that interaction synchronous, or can it be handled asynchronous? So do we need an instant result, or can we handle asynchronous results? And that decision isn't always easy to make. We need to look into the systems, how they can deal with that. Some systems that emit events are not able to deal with asynchronous updates. They expect an online synchronous response. We need to think about coupling versus decoupling. HTTP, I have to admit, I have a very strong messaging background, and what I find always struggle with HTTP is it is a directed protocol. It is directed to a IP address, to a port, to a URL. It is not really anonymous consumption of a service. So I'm not just anonymously address a service, but I need to understand actually where it is hosted. Whereas in messaging, I just address a destination, a service, and hope that there's a consumer listening to my request and is working on that. And that is coupled versus decoupled. We will talk about how to overcome some of the coupled challenges with HTTP later, but that is the general decision.
Polling time again. Which one do you prefer, HTTP requests or messaging? I think we know what Hendrik's preference is.
Personally, I believe there's good things in both.
Is that a fair poll?
No, it's not. It's intentionally.
It's using the right tool from the toolbox or the right job, huh?
Absolutely. Fantastic. Thank you. I mean, that is what it comes down to. My challenge as an architect currently is HTTP is a protocol that is very well understood by, or many people think they understand HTTP. And it comes with so many aspects like security, encryption, authentication, and all that kind of stuff that is standardized that people love using HTTP. The network guys, they just open up port 80 or port 443 and they say, okay, whatever you want to do, you can do it on HTTP. So I think that's one of the reasons why there is such a wide adoption of HTTP. But messaging has the added benefit of being reliable, being fault tolerant by nature, being able to like duplicate traffic and all that kind of stuff. But bottom line is it comes down to your requirement. And I totally agree what you said. It's take a decision what you need. Many of our customers are biased and think they can only use HTTP, but I believe messaging has still a strong demand and there's a strong argument in favor of using messaging stuff in our integration.
So 53 says HTTP request, messaging 47, but there's a lot of people in the chat going, it depends, and it needs one more option, so under review, etc. But this was a little bit of a leading poll because obviously MuleSoft messaging is API-led and has a very keen focus on HTTP, but it's good to see, all the practitioners really thinking about what the need is opposed to following architecture. There's a big difference between architecture and the real architecture behind what you're building.
So it's great to see that the audience really understands that you need both. And I think that's the reason why we have this like almost 50-50 split guidance. What are typically the key points I'm trying to look at? And I try to use HTTP when I have externally facing APIs. I would like to address a really wide and broad audience. Many different users from many different organizations or departments should be able to easily consume my APIs. And because HTTP is pretty much well understood and there's so many libraries out there, and you can natively call it from JavaScript, for example, use HTTP whenever you have a wide audience. When you can establish a point-to-point and stateless service, it is 100% viable to use HTTP to offer your services. Use it if it is a one-to-one communication. Messaging has its own challenges, obviously. In HTTP, we have a connection, there's something we can monitor, we have a direct data flow, there's no broker in between. So in these scenarios, HTTP is 100% viable alternative. Using thin clients, like I said, just JavaScript or shell scripts or whatever stuff that doesn't require thick libraries to establish connections to your Kafka cluster or to your Solid appliance or other JMS servers out there. I typically use messaging when I have a high volume in messages that I need to deal with. If I need to distribute tens of thousands of events per second, that is typically what I then deal or use messaging service for. If I have asynchronous requirements, and this really goes hand in hand with having the challenge of that we sometimes have slow consumers in our network. So we may have a high demand from the outset and we really want to serve all of that, but we need to buffer it somewhere because our backend systems can't deal with that. So if we want to decouple the consumer and the server side, but still accept the request, this is where I like to use messaging, as it gives me that extra buffer. And in modern worlds of IoT, more and more we see occasionally connected systems. They aren't online all the time. Just remember about the customer I talked with, these 3,000 stores. Not every single point of sale is open at any given time. So these systems, they go on and off randomly, if you will. IoT devices are not always on, and I can use messaging really to buffer that stuff and address these occasionally connected systems when they become online. Again, another value I see in messaging is that the service provider defines the speed by which it is able to process the request. So it is not getting overloaded. It can run at its own speed, at its capacity, without going down. So now we've already talked about the events and how the one event can trigger a magnitude of other events and actions in our system. When we take a step back and we think about the two major implementation strategies you can follow, there's event-driven. And event-driven really means a event is emitted somewhere and we act on the event and we do our bit of the business process and it goes on and subsequently it emits more events that are then being worked on. The contrast to that is using a central workflow engine, a central orchestrator that takes that single order, for example, and then it spawns a process that is responsible for handling that order from start to finish. And that may run for a couple of days or weeks, depending on what that process looks like. And I can go to that single engine, and that single engine exactly always understands in which state we are, and it can handle the load and distribute stuff and so on. Now, if we are in an event-driven system where we do not want to run this centralized instance that is doing things end to end, and there's good reasons for not doing that, we have a couple of challenges we need to be aware of, and that is having cascades of events that are now really triggered by multiple sources, by multiple different applications that we have in our organization, or by external events that enter our organization. All of a sudden, our system must no longer anticipate that events arrive at a particular time. Building an event-driven system means we are trying to build real-time systems. Real-time, not like what the engineers would say what real-time is, but real-time as in the meanings of a business process. So act on the event within a matter of seconds. In the old days, we would have that batch job being run at midnight or 2 a.m. in the morning, and we understand that now we have a 4-hour slot to process all that data. But today, we don't really know when the events come in. It could be a massive event, a social media event, for example, and all of a sudden we have a massive load in our systems, or other external events that trigger a spike in our load. So building systems that can cope with the fact that no longer we can anticipate when an event arrives becomes crucial. And being able to anticipate that events no longer necessarily arrive in sequence as we would expect them before is crucial to our final architectures. And that is stuff you have to consider when you start building event-driven systems. Having connectionless communication between my endpoints, and this really goes to the messaging solution, introduces additional points of vulnerability. If we have a direct connection between a client and a consumer, they can do all the security negotiating between the two of them. So they can mutually agree on that they trust either side, and they can encrypt the traffic. Now, having a broker in the middle means that there is another attack angle for rogue services out there, for bad people that try to steal our data or compromise the data we're working with. So it requires a different approach to security when we build an event-driven system. We need to build it for the unknown. There's so many things we don't know when we don't know how many events are going to arrive, what the load is going to be, what the expectance is when it comes to latency, what the data quality may be of the events that we get. So we have to build more resilient systems. All of that is already tried or is being addressed with the advent of microservices. This one of the reasons is we build microservices is that it's more easy to address these concerns in smaller services and smaller building blocks, rather than having that one big application that needs to deal with all of that. The downside of that, obviously, is now we have all these individual components, these smaller pieces that are able to deal with an event. We are adding complexity to our documentation. It is no longer that single document that describes exactly how we handle that order, but we need to exactly now document like all the different services, how the data is being routed. We need to think about how can we trace and test in a distributed environment when we don't really know when an event happens and when it's being worked on. So it requires a change in mindset when we build event-driven systems on how we do all these things like tracing, testing, troubleshooting, error handling. And the tooling is limited. The industry is inventing new stuff and more mature stuff and less mature stuff.
We've got a question in the chat. Messaging is loosely coupled in one sense. The transport, however, a failure to model and abstract the data model results in tight coupling. What strategies do you have to handle this?
I think you're right that the data model is the thing that stitches it all together in the end. And if you have a change in the data model, it becomes difficult. And
I can provide a bit more context.
Yes, please.
I mean, historically, I've worked with message-oriented middleware in the past. I've worked with complex event processing. And okay, so from a loosely coupled perspective, you've got the transport layer. From a messaging perspective, you don't need to know about the broker infrastructure or Kafka infrastructure. You just send the event on a subscription or a hierarchy, and the subscribers will take care of it. So I get from that perspective, when we talk about it being loosely coupled, get it completely. But you still have to have a data architecture in order for these messages to be understood and to be consumed. So I'm just wondering, how have you dealt with that? Because one of the challenges we've had, and I've noticed someone's put in the chat that it's starting to be addressed, is historically event-oriented systems haven't been particularly well documented. The domain data models are not always well understood. In a large enterprise, it's difficult to get the consistency across business units, across the enterprise, to ensure that they interact in the same way. You still have the versioning of the data, which is the same issue on APIs, you know, how we version APIs and resources and whatever in the RESTful domain. So it's more just to kind of, you know, I assume you've encountered those issues. What have you put in place in these integration solutions that are event-based to help counter that?
You're absolutely right. Been there, actually still having the challenges every single day. The general approach to this is people come along and talk about canonical data models, CDMs they would like to implement. And then you start about like, okay, so what is a customer? And everybody has an idea of what the customer is. And then they start pointing at different standardization groups and say, well, we believe the customer should look like this. And you bring big effort to translate your data model and being able to map your data into that standardized data model. I'm not a huge believer into that. I believe there is a degree of complexity that needs to be solved for every single problem, and we need to take a decision where we want to address that. And if we address it in the data model and we try to have that canonical data model, we put a lot of effort into that. And just like you indicated, there's going to be a massive argue in the organization, and you will not find that one definition, probably not in time for the project. On paper, the benefit of having a CDM is that theoretically you could now post that customer object to any endpoint that is able to understand the customer, and it could apply its business logic to it. In reality, as soon as you need to change something on that data model, you now need to change all the endpoints to be able to understand that new data model. If you have a low number of participants in your communication, we typically tend to not build CDMs, but we build data structures that serve that business purpose. And what I really like about the architecture that MuleSoft is bringing forward with system APIs and process APIs and experience APIs is that I can have my proprietary data formats in my system APIs, and I can build data structures on my process APIs that serve that particular purpose in my organization. And when I do that, all of a sudden I realize that I'm no longer sending around like that entire customer object, but I'm invoking a service that is working on just an aspect of the customer. And for that very reason, I no longer need to send and transmit that entire customer object. There is no easy question to that. And in every project, you need to, again, overcome these challenges.
Does domain-driven data model help in removing the complexity of tight coupling with data model?
My take on that, it is a methodology on how you derive your data model. So a methodology you apply to your organization to condense what is the essence of your business object. And it helps to a certain degree to speed up the process of defining these data structures. Whether it is the holy grail and addresses all things, unfortunately, I cannot tell. I haven't used it in too many projects. What I can say is the data architect is an important role to be filled in properly with a great mind in your projects when you think along domain-driven data stuff.
When designing systems that require both sync and async communication, what experience have you had using write-through caches or other caches? Can you share any learnings or implementations?
All right, now that is really that is very technical. There are scenarios where caches are 100% useful, and others, to no surprise, where you don't want to have them. Like when you do a transaction, a credit card or debit card transaction, you don't want to work off caches. Obviously, you want to work off the real-time balance, and you want to do that like in real time everything. Whereas if you query the delivery times or like how long it's going to take to deliver a certain good to a certain destination, that is something you can probably pre-compute and put in a cache and make that available. If that question is more around like, should I use stuff like Redis or not, or Memcached or EHCache or something or not, it really depends on your business requirement in the end. If you can work off caches. Write through stuff, if you do it all right through, it has a significant impact on your transaction throughput, obviously. If you're able to cache, you will be able to handle a higher workload and protect the underlying systems from being overwhelmed by a peak in requests. Keeping caches consistent, knowing when to expire data, knowing when to update data can become an art. So think about that when you implement these sort of things, that the worst thing you can have is a cache with invalid data or not consistent data, and you don't even know it.
How many microservices justify the overhead of running Kubernetes and Istio? Is it 10, 100, 1,000?
This really, I like that question. I would hope it would come after my last slide. I addressed that when I'm at that slide. I love the question. It tells me we have an experienced audience. That is really fantastic. Thank you so much. So trying to address the stuff that I talked about, it's like the rising star obviously now are service meshes. They are around for some time. They really got traction, like I would say, like in the past 2 years. MuleSoft just released their Anypoint Service Mesh, so a couple of weeks old. But what it's good for, it's when we look into, I'm in favor of messaging. The message broker is able to throttle throughput, to limit queue sizes, to deny new requests, to have an overflow policy, to delete older or newer requests, basically to control the flow between many services. It is using access controllers to secure access, and it can enforce SLAs. So if you're not familiar with, you probably really want to check out the Solace messaging infrastructure piece, because that's doing a great job on doing that stuff of forwarding requests. When we think about HTTP, it wasn't available simply in HTTP. You had that client that directed IP traffic that goes to that very endpoint, and the endpoint had to deal with this. And we realized that ain't no good. So if we build microservice architectures where we run the same service in 10 or 15 or 20 more instances, how do we easily distribute the load between that? Load balancers will help to a certain degree, but only to a certain degree. They don't understand what our services are doing and what their computation weight might be, and we may be interested in having more complex routing logics. And that is where service meshes came along and said, okay, so let's build a runtime environment which we can reconfigure at runtime easily to route the data reliably between instances of services. where we can introduce cross-cutting concerns like monitoring and security and other SLAs and enforcement without telling our services how to implement that. So basically provide an operating system for our microservices to secure their availability and scalability. So that's really where service meshes come from. And if you think large scale, I believe you have to investigate whether your organization requires such a service mesh or not. 10 years before today, we had API gateways. So we were just doing the stuff that I said with the load balancers. We tried to do it in an API gateway and enforce policies, have throttling, have logging, just for that very API endpoint. But how do we deal with stuff that is happening internally? Do we really want to pipe it through an API gateway all the time? Most likely not. And that is where you start really being in the need of a service mesh. The poll, now I'm ahead of Jay actually, the poll for this would be, have you ever used a service mesh?
So this is a fairly decisive poll, I think. Only 12% have said yes, they have used a service mesh. 88% have said no, they have not used a service mesh. That's interesting.
So that's probably the right point to come back to the question Gavin had, and that is, hey, how many microservices justify the overhead of running Kubernetes and Istio? Because Istio is a service mesh implementation, and I would believe you would run that overhead if you go beyond the 3-digit amount of services. I believe you can still easily manage 100 services and more if we think about the Anypoint platform, using the Anypoint platform features. You probably have to add a bit of tooling yourself around that, but still you will be able to run that. On my last slide, I will come back to this again, but I would not run Istio or any other service mesh just for 10 or 100 services. I would think it's an overkill. Now exceptions obviously apply. You may have a very specific need for things, or you may be preparing for stuff that could make the case for implementing a service mesh. But if you're running in the low 2-digit range of services, it's probably not worth it. So my little checklist is, again, what is a service mesh? It manages your communication between services in distributed systems, because that is what we ultimately are building. We're building a distributed systems for running our business processes on, and we somehow need to manage that communication. It adds dynamic service discovery and traffic management. So when new services or versions of services go online, the service mesh should be able to maintain a a directory where other consumers can go to and find their service and know about the state of the service and understand how to invoke that service. And then the service mesh should be able to forward that request to the real implementation. It must implement your cross-cutting concerns, identity access management. Remember what I said about zero trust architectures. Do not trust anybody, not even in your own network. Only grant access to resources after proper authentication and authorization. Enforce rate limiting. Make sure your system does not go down from that rogue invader that is trying to run a DDoS in your environment, or probably just a wrongly configured system. Enforce that. It adds a standardized way of logging so that it's more easy for you to track and trace your transactions and whether they are stuck or broke or whether they succeeded. It will be on the critical path. Istio goes down or Anypoint service mesh goes down, everything is down, because it is the thing you need to have running. It is orchestrating your data flow. So make sure you understand how to properly operate a service mesh before deploying it large scale. It has the trade-off. It has lots of benefits. It has the trade-off of adding complexity and requiring significant runtime resources, because it now needs to, I don't have a slide on that, but when you think about how the service mesh works, the request comes in, it is intercepted, it is validated, we find the destination, we route it to that destination, we update our SLA governance tool. So very easily that single transaction triggers 5 or 10 more transactions just internal to the service mesh for its processing. So we need a significant amount of CPU and network bandwidth to support a service mesh. One size does not fit all. that's really what I'd like to say as my almost final slide here. Again, coming back to the question of Gavin, when should I employ that? It depends on your environment. So, and that means the size of your organization. If you are a very small company, a very small team, you probably do not have the resources to run that extra bit of software. You probably want to offload that to a service provider in that case. It depends on the scope of your integration. Do you really have the need of all these features? Are you building just in-house integration with no external facing systems? Do you understand your workload very well, or can you predict your workload very well? Do you have other security means and logging means in place already, probably, that you don't need to address? Take that into consideration when deploying this. What is the availability of skills and tools? And this is probably one of the most underestimated challenges in my customers. There's the brand new hip tool, and they want to play around with that, and they want to install it and run it, and because it's more modern, they fall in love with it. But being able to master these complex tools is an art. So be fair to what are the skills in your organization. If you really understand what Kubernetes is, for example, and do understand what software-defined networks are, and understand how routing and security and all this stuff works. Because if you don't understand it, you will end up with a bunch of technology that will master you, and you will not master it. The majority of your environment, are you in a rapidly growing environment? Do you have a plan for the future? Do you have a vision? Or are you in a long-term established business that doesn't change much anymore? That might help in making the decision whether to use this new service mesh tool or not.
How is service meshes different from runtime fabric? And I guess a follow-on question or sub-question is dynamic service discovery the difference?
So I'm not that service mesh 100% expert. When we talk about runtime fabric, that is really just being able to orchestrate, to my understanding, the Mule runtimes, being able to easily deploy instances, run clusters, scale my applications. The service mesh is meant to integrate non-MuleSoft endpoints also. Like they could be built in other technologies. Other API endpoints you probably have in the organization can easily now being orchestrated and added with SLA monitoring and rate throttling and all that stuff without them being required to redo their interfaces. So it is complementary. You can have both. You should have both if you are in a bigger organization, most likely.
To also add on top of what you've answered for runtime fabric. So runtime fabric is really a deployment mechanism for deploying onto cloud environments where Anypoint Platform is kind of managing provisioning of EC2 instances, etc., and deploying Mule on top. And service mesh is more about controlling east to west traffic as opposed to north-south traffic, which is what API gateways tend to use. And that's sort of a similar question Jitin is also asking, which is service mesh is only for non-Mule applications, or because Mule apps you can manage things like throttling, etc., through Anypoint Platform. So I'll take a stab at answering that as well, Hendrik, and I'll pass it over to you to answer as well. So service mesh gives you more than just throttling. So things like circuit breakers and a few other patterns and client-side load balancing, which you cannot really get if you're just managing an API through Anypoint Platform and using the built-in gateway capabilities within that API. So it addresses slightly different concern because you're kind of moving that into a separate component. Therefore, you can add more functionality into those parts.
I think that is perfect. This is. I really like when you said it's rather than north to south integration, it is east to west. I think that is true. That is probably the best way I've ever heard it to being explained.
As for my understanding, the service mesh was only for the non-Mule applications, right? But did you came across like how you will manage the Mule ESB solutions, which doesn't have an HTTP listener, but another listener like JMS or something. Did you came across managing through the platform?
With JMS, you don't typically need to rate limit because actually the consumers go as fast as they can. And if you need to go any faster, you spin up more instances and you have a competing consumer pattern to handle ratings. So the same concerns are handled very differently. And I think, Hendrik, you were making a point earlier in terms of service meshes, try to address some of the concerns that are naturally handled by messaging, because messaging is a pull mechanism and HTTP, etc., is more of a push mechanism. And with a pull mechanism, actually, the consumer is always pulling as fast as you can.
In fact, with Chirag, yeah. So in fact, with service mesh, generally what they say is if MuleSoft needs to give the capability, then they can offer only with Mule 4. But with Mule 3, the capability of using an external service mesh based on Istio, it's most likely not possible to manage Mule services at the moment, I believe, but I may be wrong.
That's interesting, Chirag, because I would have thought it's a HTTP endpoint, right? And service meshes can manage any HTTP endpoint, but that's an interesting position from MuleSoft.
Yes, so somewhere the control plane, the management plane is not supportive for Mule 3 because the agents cannot be. So I cannot use non-Mule services with MuleSoft platform. With Mule 3, I have to have Mule 4. And even otherwise as well. So there is a bit of a gap up there, but yeah, I'll pick up the notes. I'm picking up the notes now, and possibly towards the end of the session, I may ask questions.
Talking about the build versus buy decision. So now you probably made up your mind and you took the decision and said, yeah, service meshes is probably what we need. So it's the build versus buy decision you have to make at that point. And as said before, integration matters also as the software vendor, so you probably understand on which side I am. But let's look into what should drive your build versus buy decision, apart from the stuff I said on the previous slide, and that is think about the total cost of ownership, and that means how expensive is it to develop and maintain and operate and support and eventually retire the solution you're looking after. If it is just a small thing you're looking for, building it yourself may be beneficial because you understand what you do and you do not need to learn the stuff that you don't need. In the contrast, if you grow after that decision and you have to build everything on your own, all of a sudden, rather than becoming a solution provider to your business organization, you become a software house inside your organization. And that's the least thing you want to be in when you're doing integration. You do not want to develop software. You want to use the stuff to rapidly deploy and update business processes. And the total cost of ownership is more than just looking into how much it costs to develop it. It is, or versus license cost, because that is what I typically see is that the first two, development and maintenance, is what the majority of our customers compare when they build stuff versus buying stuff with the license and maintenance that they use for commercial product. But you need to think about how do you operate things, how do you support things, and that is where typically commercial products excel because they need to do this and operate at scale for hundreds of customers and more. As said, do you have a custom need or is it a general function you're looking for? If it's just a custom need and a very particular custom need, you probably want to build it yourself or using a very small framework out there. But if you think in more general things like, okay, I need to have access control, I need to have certificate management, I need to have SLA governance, that is a general function. You really shouldn't build it yourself. And finally, staffing. Who's going to build it? Who's going to maintain it if you build it in-house? The same goes when you buy a solution that you have to run in-house. Who's going to operate that? So think about, again, the capabilities of the organization. And the service meshes have their place, but not every place is the right place for them, if you're getting what I'm saying. My final slide. Whatever you do, know your environment before you start doing things. Be fair to yourself. Do not overestimate capabilities and do not underestimate the challenges along your way. Know your capabilities, know your direction, be in close contact with the architect, with the visionaries in the organization. If the business will transform itself into a service company, for example, service measures might be the right way, and event-driven architectures might be the correct way for you. But if you are in a well-established scenario, probably in a regulated environment, it is probably not your domain to do this. And my final word is, not all of us are FANGs. Yeah, the majority of us are much smaller than Facebook and Apple and Amazon and Netflix and Google. So even if they have the most fancy and shiny tools out there, if you're not at their scale, the tool is probably a bit of oversized. So try to find something in the mid-market. And that's my final words.
Thanks, Hendrik. I think we had a lot of questions, so people are obviously very, very interested in the topic. And Hendrik, I suggest you read the chat. Many people giving their thanks to you. Thank you again. We really appreciate it. So Jay Rajani is from Blue Harvest, and he's going to talk about his experience of really decomposing a monolith, if you like.
Thank you, Jay. We are like a name check. So today, guys, Hendrik really mentioned about the complex event and also the service mesh. This is more short of a modern approach towards the modern architecture. My presentation is more towards the experience I had with breaking down the monolith with microservices. Mule has been always a soft corner in my heart, and I use Mule to convert the monolith into microservices. A lot of questions were raised at that time, why this choice and why not this? So maybe I will try to highlight what had been my journey towards this entire project. And I will share key learnings from my side, and will be also open to questions that if you are going through the similar process, a similar use case, then I will try to answer those questions as well. So my name is Jay Rajani. I'm originally from India and working in Netherlands as a technical architect in Blue Harvest. My focus is more on Java ecosystem and mainly in event-driven architecture. So I'm a very big fan of Mule as well as Kafka. And I also started doing domain-driven design. Earlier I was doing it, but I didn't recognize that it's domain-driven design. And then suddenly this entire microservices era helped me to grow my skills on domain-driven design. Apart from mixing the frameworks, I also mix a lot of spices when I make some dishes. I am fond of cooking and also playing table tennis. Blue Harvest is a very small company. It's an elite engineering unit of Capgemini. We have been established 2 years back. And we are more onto a kind of a culture away from the corporate culture. So we are more into technical excellence along with the emotional intelligence, because in the financial sector it is difficult to only deal with the technical excellence. And the very big reason for this is that whenever new technologies are introduced, there are only 20% of the adapters which go to the technology very quickly. But then there is 80% of the people which require some support to move on, and that is what we are doing. And we are also working in ventures. So we create blueprints, made this blueprint open source. So if you are really into service mesh, and if you're looking for something readily available cloud independent blueprint, I think it is good to look at that. Or also you can contact me. Today, I'm going to talk about the application that we were working on, the Monolith, the decision why we went to Mule and how we started breaking down. The biggest change that we did was also bringing the event-driven platform and what kind of challenges we had. I would like to explain the domain a bit, because then I will be using a lot of terms, and maybe it's good to have a little bit of idea what the application is about. So we were working for a lease company which has an which has an ambition to develop an application that can be used by the lease person to park the car, to fuel, and also at many point of time you see the food and drinks counter at the petrol pump, so you can also use your application for that. In the Netherlands, there are a lot of food and drinks chain, not as big as we have in UK, but very big. So the biggest USP for our application was the fastest search based on geolocation, which was supported by solar indices. So this was the application that we started with. So we had the consumer APIs, which provides you the details about the merchants and also their catalogs or locations for parking. I changed some names as My Apps and My DB just to for the compliance point of view. And we also had the merchants channel where you can, for example, if you are driving and you think that there is a subway 10 kilometers away, you should not use your mobile while driving, but the other person can order something, and when you reach to the petrol pump, the order is ready. So you also have the POS interface along with the external services that we were using. One was the printing service at different merchants. And another was on the parking. I name it as SHPV. The SHPV is a parking provider in the Netherlands, which has approximately 60% of the parking places integrated. There comes the first poll. This is anybody would like to also maybe share their experiences with maybe this kind of application. Like, what will be your impression if you look at this application on like the first impression?
For me, it's very typical kind of 3-tier. You know, you've got a presentation layer, you've got some sort of service business logic layer, and you have a persistence layer. So it kind of follows that very simple 3 layers approaches. There's some sort of potentially data replication going on between the two MyDBs.
So this was a normal 3-tier application along with the solar indexes that makes the geo location search very quickly. This kind of architecture is sometimes very easy to see, but whenever you allow any architect, you will have a lot of comments in terms of that this is not correct or that is not correct. And also, when I was in that situation, I felt like this Indian mythological story, like blinds and the elephant story. So when a lot of blind people wanted to see an elephant, and the king gave his elephant just for for touching and observing and get a feel of what is an elephant. And some people think that this elephant is a spear, whereas some thought it is a wall, and some say that it is a rope. This is what exactly happens with the Monolith application. And whenever I go through any customer and see this kind of application, I would like to know what is the purpose of the elephant. If you want to ride on the elephant, I think the elephant is fine. You don't need to change an elephant to a horse. Maybe it is faster, but if it is something that you have to invest a lot, I think elephant is fine. Looking at this application, we had a really scalable printer service network, because we had this external service, and the external service could easily scale to any number of printers. We also had good working parking flow, and all of this were very simple, very extensible. But now the application was built on a Broadleaf framework, and this is also something that this is on a side note. I am only having one slide here, so don't worry, I will not talk about this framework a lot. We were using Broadleaf framework. Broadleaf framework is an open source e-commerce framework, which is Java and Spring compatible. What it does, it gives you a set of workflows. So for example, if you need an order workflow, if you need a promotional workflow, it gives you those workflow readily available. And these workflows are designed in such a nice way that you can introduce your own process within the workflow very easily without disturbing the entire framework. And on top of these workflows, the framework itself is so light that it does not add too much of overhead on your application. So it does not say that you have to also bring this framework together, or you have to follow this and this pattern in workflow. This thing was going really well. SHPV was also going really well, but when you provide this partner integration to the company, and the organization it becomes like a kid. Huh? So I always say that their partner integration is like gifting a dinosaur toy to your kid. So if you go to a McDonald's and McDonald's people give you this small toy, even if it's a dinosaur, I think it's a big headache for you in future. And why I say this? Because dinosaur does not come with one form. You have so many forms of dinosaurs, so many toys around this. And then your kid also wants to make a collection of this, and you want to have one more philosophy there. And this is the same thing happened with our application. We had like 60% of the parking locations covered, but now the organization wanted to expand this to another parking provider. And on top of that, we had only 2 flows earlier, the order flow and the parking flow, but now we also wanted the tank station, and tank station also became more than here, and you can fuel with your mobile. So this is something where we also see that increasing number of transactions causing performance issue on the system. And we also wanted to increase towards B2B channel. So we wanted to have other lease company just using our APIs can also create their own applications. Does it take too much long to introduce a new technology at your client location?
Jay, I'd just like to comment on that really nice elephant picture you gave. I was looking for something like that for a long time, and I think that is exactly something the majority of us have experienced when they build big projects, that depending on whom you talk to, they only see a fraction of the entire picture. And when I entered the integration space, I immediately felt that one of our tasks is to fully understand the environment we are acting in. We cannot simply focus ourselves on a single aspect of the solution. We need to understand how this all hangs together and what the entire process should look like. And why that is a big privilege, it is also a huge challenge typically. It really summarizes the challenges we have when talking to bigger customers and trying to digitize their processes.
And you rightly mentioned, sometimes as an architect, when you go to the client place and you also have those marketing people around you, it is really difficult to sometimes get enough time and understand what the elephant actually is, and then come to another perspective of the elephant and think whether we really need the elephant. This was the first requirement where we had so many parking providers and also the B2B channel, and we were kind of struggling with the load. So this is where we also thought what to do. And being an architect, my first attempt was to a little bit separate out the external integration from the workflows that we have. And that is why we introduced Mule. And the reason why we introduced Mule, the first reason was that we had so many connectors, and also it is very easy to connect with external system, and rather than reinventing the wheel and reinventing the client itself, you can do some configuration and your connection is ready. Second factor was that we also wanted to start with event-driven architecture, and with this kind of 3-tier application, looking at the event-driven architecture was quite a challenge to change the mindset in the organization. And also the third reason, we evaluated so few ESB at that time. We had also Fuse and W2O, I guess. But looking at an Anypoint Studio, Anypoint platform was not introduced at that time, so we were mainly with the Mule runtime and also the Mule Studio. The Mule Studio has this capability of drawing the flows with a simple drag and drop UI, which was quite an easy win to start making your skills in this segment. So developers were very enthusiastic about how they can easily draw the flow, and then in the background the configuration has been created. So that is our reason why we went for Mule. But you run into this kind of problem very easily, where you start with one thing, but then the problem becomes quite complex. So we had this Mule flow where we had the SHPV as a parking provider 1, and the parking provider 2, we had another service, and we created simple routing over this. But now think of a situation where you get a geolocation. You will first go to the parking X. You will see whether the parking is possible using the parking service or not. Then you get a failure. Then you go to parking provider 2 and see whether this provider provides the parking or not. And you have tons of providers, so it is a bit difficult. And this number can go up to hundreds in the Netherlands. So we needed some inquiry API. So we had the government subsidy with them. We also helped them to develop this inquiry API. And that inquiry API was kind of an enricher, or the transformer that can find out which parking provider is related to your geolocation. So we, based on the geolocation, we go to this parking API, and then this parking API tells us where to route. And then we can go to SHPV or to the links based on the provider that we found. The next question for the survey: are you dependent on other teams to release your own feature?
So why did you select that Giphy? That's
yeah, it's sometimes you actually rely on the other team so much that your own on changes becomes like a legacy, huh? So in a way you are hitting the X on your own leg by waiting for others, and frankly speaking, this is quite normal that when you are introducing some technology, you want to have quick changes. And the same thing happened for us, that for when we introduced Mule, we wanted some rapid changes towards the integration environment. And that is what also happened in our case. The broadleaf monolith became so big, and workflows are also extended so much that the speed of the team which was working on the broadleaf framework was slowing us down, and this was something which we cannot in a way tolerate, and that's why we started introducing a new philosophy in the working style. We call it process API, but the idea at that time was to expose the service using some interface, and REST was the best solution at that time. So we introduced REST API to also consume your own flows internally. When we introduced this, our idea was only to separate out these two teams very easily. I will show you how that became a better win and later point. With the process API, I think that was the first attempt that we did, which allowed us to create the first microservices out of this monolith. So we had broadleaf workflows, and then we introduced the Mule ESB. We had two in the same runtime connecting to the different external providers. But then we move on to exposing our own API, creating separate runtime, and also managing our own scalability, and also connection with the external parties. Our microservices was actually connecting to 3 different providers. We kept the old flow, the printer flow as it is. Yeah, we didn't work on that at that time, but this is the first first breakout of the big monolith into a mini monolith along with first microservices around.
What if that parking API needed access to your database?
Yeah, very good question. I didn't draw the database here, but we also had the database for parking, and also we had the Solar indexes, and that is something that we also use as a way of consolidating different databases, or I would say putting projections towards the Solar indices. So we had the food and drinks, we had the parking, and then we also introduced tank station, and you have all the services creating your own orders. So we introduced order APIs, which can give you an consolidated view of this. But then this order API is something that you cannot put in a specific microservices, because this is more sort of a shared kernel from the DDD point of view. And the Solar indexes also helps you to kind of create a simple model out of all different models you have in the individual API.
You mentioned an interesting term there, projection into Solar indexes. Can you kind of expand on what you mean by that?
The first difficulty we had with first microservices was to have the different order format. So for example, food and drinks has like number of items and those kind of properties. Whereas in parking, we had more sort of like the parking start time, parking end time, and based on that, you are actually paying for the parking. So for both sort of orders, you have different set of properties and different set of parameters. But when you actually want to go to the application, you want to see all those orders one after another. So for example, if you did like a parking order and then you did some food and drinks order, you still want to see where did you do your transactions. So for this transaction, what we used to do, from whenever the order has been created, we'll create an index on the Solar, which in short of creates a kind of a projection model or read view on these orders, which has some designated properties that you want to see in the receipt. And both the broadleaf as well as the microservices does this projection towards Solar. And yeah, these projections are hardly updated, because once the order is created and paid, there is no more events on the order. So when we designed the process API, our first goal was to become independent of the source system, also the data origination. So in this case, it was broadleaf, and some sort of also the target channel for the data delivery. But I think that was not possible only with process API. So we also introduced another step. I will come to that later on. Also, we started thinking about the consumers, our own internal consumers as client. This was also biggest thing in the introducing the process API, because till that time there was really less documentation and less Swagger APIs for each other, because everything was in like a big monolith. But now when we separate out as a process API, you want your consumers to be self-served. So we created also a proper Swagger so that they can interact with the playbooks, and they can manage contract from the Swagger itself. And also with every release of the process API, the documentation evolves as well.
We got one more question. Did you experience any significant difference in response time when you move from monolith to microservice?
Yeah, response time. I heard some figures I recall as well. I remember when we created the first order history screen, we had some sort of like a 20 millisecond response, and that was because we were consolidating data from different databases based on the REST API calls. But then with the process API introduction, we had minor win. It was like a little bit of a couple of milliseconds, but But then the biggest win we had when we introduced projection towards Solar, because then it came down to like less than 2 milliseconds as well, and that was, I think, the biggest win. So when you are creating the microservices, and if in a certain situation you make a call from one service to another service, I think those calls are very expensive, and you have to find out some way to make this faster. That can be something like a Solar or maybe another approach.
Yeah, so really a good example that you are citing here. So what I have seen is, like, when we are going with the microservices approach now, what MuleSoft says is you need to deploy the separate layering of the APIs, the system, the process, and the experience. Now, from my experience, what I have seen, like when we go with the system level APIs and then the process level APIs, there's much orchestration which is being done on this system APIs. Like there might be some serial calls that we need to do to the APIs, different sort of APIs. So we have the scatter and gather, which is at time handy, but I mean there are situations where we have to do this serialized calls, like one after the other. The second call on the API is dependent on the previous one, something like that. So going with the monolith approach, now IPC is always faster than HTTP, right? So there's no denial on that fact. Now when we do this, like, do you have any good suggestions, like you or Jairam or anybody from this group, like how should we go about with this approach? Because layering of the APIs is good, it's a beautiful architectural front, but when we go into the practice, or when we do that practically, there's this lags that we notice, like the TP hop that we call.
I think that we also had similar example with the Fuel API. I will cover that later on. But I think to answer this question, I have to also understand whether the scenario you mentioned, where you do like a serial sequential call, is it also possible to do some event-driven ways there?
I'll sort of take a stab at answering the question as well. So there are two approaches. Well, there's a couple of approaches really, and you've mentioned scatter gather, but obviously that's not available to you. Can you cache the data locally? So rather than it being a HTTP call, it is it's a call within the process. And if you are looking at cache, if that's not possible, can you subscribe to events to keep the cache fresh? So again, going into a more of a CQRS style model, where actually services that need the data are actually holding copies of the data for lookup, etc., rather than making an API call, which is actually somewhat different to MuleSoft's architecture documentation, if you like, where they talk about reuse, and they say if you expose a service and every single domain within the organization can call that service and reuse that functionality. But it also means you're starting to tightly couple, because that means all of those organizations is now dependent on that particular service. Whereas if that data set was available and that data set was replicated and reused by different services from a local copy, then actually there's less of a dependency there, because actually that data set can be then scaled independently by each of the the different domains, etc. So there are some kind of, I'm going to call it EDA principles, but they're EDA in the sense they're more data streaming in terms of Kafka, and less event driven in terms of TIBCO messaging and etc., which is kind of event driven from maybe 10-15 years ago, if that makes sense.
Right, got it. It depends on the situation, like whether we can do that or not. Like caching is not always supported. I saw that in the beginning of the session also we had certain questions related to that, but I like this idea of subscribing to that. Like if there is a change, then the cache invalidates and a new fresh copy is there.
There's a principle that I kind of just shared with a friend recently, which is centralize an immutable stream of facts, and decentralize the freedom to act, adapt, and change. So once you have something like Kafka, where you're storing a stream of events, actually you no longer need to go to the database to know what the latest status is on a particular given topic, because you can subscribe to that and you can maintain your own status, right? If that makes sense. But it does mean that you will end up with duplicate services in each domain, because, for example, you might want to look up the latest status on an order, but then you have an order lookup service in every domain. But that gives you agility, right? Because each domain has the independent, and they're not dependent on another team for an order status lookup service.
Thanks for pointing out about CQRS, Jay.
If two services need to share the same data, would you duplicate the data in each service, or would that be an indication that there should not be a separate service?
For that, if I look at this application itself, we created a shared kernel APIs. So, for example, the order APIs, the user APIs are those APIs which are basically used by all other microservices. And at that time, it's also good to understand who knows about this ubiquitous language. So, for example, the people who are working with the parking service may not be the right person to use the right language. So, at that time, I would prefer if this kind of shared data can we define as a shared kernel and handle it as a separate maybe service. Sometimes the data it can be like really small. So for example, we had also the address service. The address service was mainly to manage the receipt, the shipping address, as well as like the billing address. I forgot the right word that we use in this application, but so this address service was also something which we were thinking to separate out, but it is not that big to make a separate service and handle the overhead. So we combine that along with the order service. So at some moment you have to take those kind of decisions as well.
We got one more question. If we have a huge data set to retrieve from the Monolith system, is it good practice when you're writing a microservice to retrieve extra data set or just the data set that you need?
Very good question, and that is why I really love Solar. Most of the validation, and also if you are aware of the CQRS pattern, general in CQRS, when you are doing the command, you cannot actually go to the event history and check the events. When events are in bulk, this is short of impossible, and that is why you have to develop something which allows you to do this kind of validation together. And for us also, we had this Solar indexes. We also use that for some sort of validation. So for example, when we had this merchant service separated out, you also want to do certain validation on the merchant. Say for example, whether this merchant itself is a parking merchant or not. So in that case, we prefer to do the validation against the Solar document rather than actually calling the service itself. That was about the process API, and I think that was also the time when we were really thinking, do we really understand our code base? Because then we have a lot of one big monolith, which was the Broadleaf framework, and how can we continue with that code base, which is becoming a bit legacy now. I also put this question in the survey. I think this will also help you to, in the end, in the results, I will share why this question is also important. So in the end, we went to some sort of like a very high level. I put from the responsibility point of view, and didn't divide it into the microservice level. But so this is how we went, because Broadleaf was so good in terms of managing the workflow. We never wanted to get rid of the Broadleaf itself. And then we also had this process API design, which were really a good way to directly use the business processes. So we had, I'm not sure whether the cursor is visible, but we also introduced the marketplace. And for that, we use the W2O solution. And the marketplace was also used for internal and external client. So whatever API that your team or your service has, you should expose those APIs through Marketplace. And this marketplace will be the place where the internal people will use directly without any problem. But for partners, they can use based on OAuth, and we were also charging the partners based on the SLS we had. So, and based on that, we can define different pricing tier as well. And the shared kernel that I was talking about, we had a separate team focusing on the shared kernel. So they were mainly working with three sets of APIs. We had order APIs, user APIs, and authentication server. I call it auth APIs here. But all three were separate microservices and one team because those three were considerably smaller services, so they could be handled by one team easily. Whereas on the actual service side, like for example parking, we had the experience API calling the parking workflow, and that parking workflow basically takes care of the entire flow using the Mule ESB and routing to the right provider. So if I look at if very high level, maybe if I would have drawn some boxes for every microservice as well, these two lines might have been the microservices that we designed. But we also had like the promotional workflow and also the solar indices, and that were basically the core of the entire system. And we also had this broadleaf e-commerce team which was taking care of this. But eventually we could manage to separate out at least 10 different microservices out of the big monolith. And then the services of the broadleaf e-commerce was very specific to managing the workflow and also to the experience API and the partner API, which was making it quite light in terms of the load as well. We also had to define some global strategies that we wanted to follow, and that comes into the monitoring and as well as exception handling. The biggest point I also didn't talk about so far, because you might be wondering, we had this SHPV and links and all other parking provider. They must have their own different model, and yeah, that was the biggest problem. For example, in the parking, there were certain providers which tells you that you have to enter the end time. So for example, if I'm starting the parking right now, I have to tell them, okay, this is like 1 hour parking, and I put this information. But there are other providers which does not ask for any end time. So you just click on the start button and you just forget. And like after, whenever you are taking your car, you just stop it. And if you don't stop it, you also get like after 2 hours or 3 hours configured time, you get a notification, which helps you to just recall that if you have forgotten to stop the parking. So this kind of differences within the way the provider handles the same process was also a little bit of headache for us. And that's why we also created an API for the SHPV and links. And I forgot the name who asked this question, but when you are talking about system API, I think this was the place where we had sort of the APIs that were customized to the provider itself. And this was also, if you look at the DDD terminologies, we had this layer as anti-corruption layer. So every provider that had their own data model, which was also affecting our business, and especially the code base was more on the assumption basis, which we wanted to remove. So this is sort of the defensive strategy that you can use to isolate your own business model from this kind of provider's data model. Another benefit we had was that this gives us a sort of plug-in and plug-out facility for the dependency. So tomorrow, if Link says that, okay, we are done with you, we do not want to work with you, we can just pull the plug from there and our routers will immediately handle it. So it was also the reason why the system API, or at the time we called it anti-corruption layer, was helping us to deal with different behaviors.
Pause for a quick question there. So Howard is kind of presenting a view where whether the solution you're presenting is more SOA and less microservices, because you need, from a monolith perspective, are you really just changing the solution architecture and you're solving a solution architecture issue? So maybe you can elaborate a little bit more on where you think the monolith is and how that's been broken up.
I think when we started this application, it was like around 2012-13, where microservices was still a very new concept. SOA was more sort of a high-level base for microservices at that time. And I think right now also we are quite struggling between whether SOA was actually the microservices or not, but that's a different story. For me, the SOA was more sort of the initial idea of defining how the services can work, and microservices gave a little bit of detail patterns and ways to break down this and also really make the services work together. So I would say yes, in a way, because the SOA was our initial inspiration. But later on, how this microservices world evolved, we also evolved together, and we also had an adoption to the cloud technologies, and that also made our life a bit more easy in terms of handling certain services. If you look at the overall picture, the first picture that I shared, where Broadleaf was solely responsible for the parking API as well as the SHPV API, though they were not APIs, but they were some sort of modules within the Broadleaf e-commerce. And the entire e-commerce was working in a single JVM. So if you want to also scale those services, you have to actually duplicate the Broadleaf e-commerce. With the platform in the end picture, we had this Mule service, which was scalable on its own. Same as the Fuel API, they were also scalable on their own. And if you look at the shared kernel, say for example the authentication server, which can directly work along with your API gateway layer, so making it completely separate from your Broadleaf as well as your other microservices. So yeah, I would say we eventually, from monolith to SOA to microservices, we evolved in this way. The question that towards from SOA to microservices, I think that also was the case for us for API-led connectivity. When we started developing this, we didn't have this API-led connectivity model in our mind, but when everything worked out, we short of I went to the Mule Summit and see the same model. We use different terms, but sometimes they are similar. That is why I included the Mule picture as well. The last service that I want to cover today was about the Fuel API, and that is where I think it will also answer the question a little bit on the sequential call. We had similar problem with the Fuel API, because then you have to wait for the fuel pump, and then when fuel pump is ready, you actually do the transaction. And this was like, if you do it in the synchronous mechanism, it is really the difficult transaction. And for example, sometimes a fueling session can go up to 5 minutes, which is quite challenging for any system. So if you do not bring any event-driven way, making this transaction is short of difficult. And that was also an unusual flow for mobile, because mobile application were also more with the parking. We were more used to of sending a request and then just receiving the response and just do the business normally. And we also had short of no experience in the team to build this. First thing we did was more onto the mobile application to find out the other ways we can handle this, and especially the local push and those kinds of things were really in good help. And then we divided this entire flow into certain events. So for example, the first one was about a heartbeat received. We had a connection, socket-based connection with the fuel system, and they were sending us the heartbeats for every pump at a certain interval. We were using these events, and these events were quite enormous in number. So we were aggregating those events, and we were finding out whether the pump is live or not. So whenever somebody reaches to the pump to fuel, they will just click on the mobile app, and they will see whether the pump is live or not. And if it is live, he will just click on the reserve pump, and the system will inform us that somebody wants to fuel. So we will generate an event called pump reserved. So no more requests on this pump will be allowed from that event trigger. And then the challenge comes, because the person will lift the nozzle and then he will start fueling. And this is like really time-consuming event. We had cases where people sometimes just go on talking, and then it takes like 5 minutes to finish the fueling. So we created two events: when the person lifted the nozzle, and when a person finished the fueling by putting the nozzle back. And these two events will help the server to send the push to the mobile, and also mobile will come to know that the transaction is over, and now they have to present the receipt on the screen. And we also, for the receipt, we had because now this is not a synchronous transaction, so we were not doing on the moment payment. So once the receipt is generated, the customer has to pay. Yeah, you also have some sort of wallet credit in there. So we make sure that the payment will be received, but it is not immediate, unlike parking and food. As I mentioned, with the heartbeat, we had to aggregate the events because the heartbeats were too much, and it was overflowing over queues. The biggest problem we had in this entire project was to find out what the shared kernel looks like, and it is quite challenging. You end up doing mistakes, but I think that's fine. You may end up grouping the shared kernel in the wrong API service, and then maybe later on you decide that this is not the specialty that your team is focusing on, and also not helping the service. You can change it later on as well. The API mindset was also a drastic change, I would say, not technically, but also in the organization itself. And for that, we made like simple rules. If your team is working on a specific service, you expose the service as functionality, and your data is not exposed directly. You expose the data also via the service, via the API. And every API has to be designed to be commercializable. So for us, parking API, fuel API, everything was commercial. So the moment we developed this API, there were partners to consume it. So it has to be commercializable. And the last thing we did was about the playbooks. And I think this is also an important point. Sometimes we only develop the Swagger documentation or some API contracts, but sometimes we miss the entire journey, customer journey here. And that's why playbook is very important, especially if you have the case like fuel, which is totally event-based. It is not easy to just go through your contract and see how the flow might be working. And the question is, do you wake up with a knot in your stomach on production deployment day? So when you are releasing, do you have like a tight stomach? I think with this, my slides are over. I just put the last quote from Martin Fowler. He said that almost all the cases where he had heard about system which was built with the microservices from scratch ended up in serious trouble. And this is really true. When I see my journey, I think dividing from monolith to microservices was an easy, not an easy, but like compared to it, that was an easy problem than starting with so many microservices from the scratch. And yeah, that is it. I will just start the survey. So these are the questions that I asked. A very good response, I would say. The first question was about a huge database. 67% people say that they are not using it. Very good. does it take too much long to introduce a new technology? And 70% are there. Please remember that for one question, the yes was on higher side at least. Are you dependent on other teams to release your feature? Again, 70% on higher side, yes side, sorry. Is your code base too large to fit in your mind? Again, yes. Wow, why the number is around 70%? Good coincidence, but yeah, really. And the last one, do you wake up with not? Thanks here, the percentage is around 52 on yes side. So most of the question, if you say yes, I think there is a high chance that you can divide your service into a further level and you can create more microservices out of it. And this is also the tool that we use many times. These are like basic questions. Here I only ask 5, but you can create more questions. Kind of a tool that you can develop for your own organization to see that you are grown. Sometimes you develop starting from microservices, but your service becomes too big. I think if all of these questions are answered yes, that means you have you should start thinking about dividing that service. Thank you very much for bearing me for 1 hour.
Thanks, Jay Rajani. I think that's been very, very useful. Question from Jitin. Do you use any messaging layer component in your flows, like ActiveMQ, RabbitMQ? If yes, then do you guys also implement the circuit breaker pattern?
Yes, when we started with the first level of microservices, we were using so the flow for parking was connected with the broadleaf via queue. I think we used ActiveMQ at that time. We also had the circuit breaker pattern implemented, but with the fuel flow, we had so much of queue overflow problems, and then we decided also with every service being exposed as API, we dropped the idea of using queues that long, and we mainly moved towards REST.
I got one more question. What was the implementation technology of the shared kernel?
They were simple Spring Boot services for order service and for the user service. But for authentication, we used some tool, but I don't recall the name of the tool. But that was for authentication, we use some sort of OAuth-based framework.
Cool. Lots of thanks for an interesting session, valuable session, etc. A lot of people making comments of first-timers for this meetup, so really good. I just want to thank Hendrik and Jay Rajani again. Really, really interesting session.
Thank you to everybody for attending and all the speakers involved. A lot of time and effort goes into putting these things together. So to see the level of engagement and thanks, it's really encouraging, and it keeps encouraging us to run more sessions. Again, seeing so many new people as well was really, really encouraging.
How have people found these sessions? What would you say is your key takeaway from this session across both the speakers and both the content?
Yeah, I think I found the event driven quite helpful, and I think one of the key takeaway for me was the challenge which I believe Kevin posted on how do we mitigate the risk with the ever changing data model. And so I just recollected from one of the case study we did with one of the healthcare customer, where we had the similar arrangement where we were just doing the CQRS sort of microservices, and we were using Kafka Zookeeper, and I think the only point I found well was we were using the data grid in that context, and I think data grid pretty much helped in keeping the data unified. So even if the data model was changing, I think the team were agile enough to respond to those changes. But I think that problem really kicked some thoughts, and I think something which we can brainstorm and see through, how to mitigate such problems. So that was, I think, pretty insightful for me on the event driven side. I found Jay Rajani's insights quite helpful as well. So thanks, Jay, about your journey from monolithic to microservices. Pretty insightful. Thank you.
No, reflecting on that, I think for me, it's always interesting to see the different architectures that are in place and the decisions and the rationale and the logic that took people there. I think both the gentleman that spoke this evening, extremely experienced and valuable to get their insights and understandings of the solutions that they've put in place. A couple of years ago when I was at MuleSoft, we went for a similar monolith to microservice journey with Addison Lee. There was a lot of elements that resonated there. And you said, what's the key takeaway? I think the key takeaway for me is integration is and remains one of the most complex landscapes to work in. And for many of us, we're passionate about it, and that's why we do it.
From the point of service message, so to understand what exactly that was, what were the major challenges that were being faced while implementing the service mesh and things like that. So that was a good insight. And that was a really session where we all jumped in asking a lot of questions because that was a new topic for everyone. Not many people have knowledge in that. So it was a good skill to understand that. A lot of good questions coming up. For Jay as well, so in most of the applications are still monolithic. So going from monolithic to microservices or breaking up that big monolithic application into smaller services, how about to go through it? That was a good experience as well, what Jay shared with us, how to go about the approach of doing it. So I would like to thank both of them in terms of understanding and the presentations, what you've given us. That it'll be a good takeaway when we're dealing with the future projects.
Thanks for both the speakers, Hendrik and Jay. I really appreciate the effort to prepare and present, and thank you for the engagement and participation from the community. It makes it easier for the speaker if there's a lot of questions to know that actually it's worthwhile presenting and there is engagement and people are getting valuable insights from the presentation. So thanks again to the community.
Again, just keep a lookout for these other meetup groups that are going to pop up in other regions as well. It's a good way to sort of cross each territory and get involved in more stuff. So once again, thanks to everybody for their participation and involvement, and to the speakers, Jay and Hendrik, who done a great job, and it seems like the feedback's